48.1. And you have to find little b equals question mark, and angle A equals question mark, angle B equals question mark. Of course, angle C is equal to 90 degrees. Okay. To figure out what little b is, you're going to be using the Pythagorean theorem. To find A, I'm going to just figure out what A is, and I want you to figure out what B is. Okay. Here's the angle A. Since we have the opposite and the hypotenuse, opposite of hypotenuse, we know that that is equal to the sine. So the sine of angle A is equal to 24.3. It's the ratio of 24.3 to 48.1. Of course, how do you find that angle A? You take the sine inverse of 24.3 divided by 48.1. I'm going to do this on my calculator really quickly. Sine inverse of 24.3 divided by 48.1, and that's going to be approximately 30.3 degrees. Approximately 30.3 degrees. And of course, how do we find angle B then? It's pretty simple. You don't have to use the trig anymore. You just use the complementariness, 90 minus that. 90 minus my answer is going to be approximately 59.7 degrees. Okay, so you don't have to use the trig functions if you want. We found out angle A, angle B, and you can find out little b using the Pythagorean theorem. A squared plus b squared equals c squared. Next problem. Oh, that was number 28. Sorry, let me write this nice and neat for you guys. 28. Okay, I know my writing's a little bit off. Sorry. Not my problem, your problem. 32. Get that? Not my problem, your problem. Angle of elevation. If the angle of elevation of a sun is 75 degrees and 30 minutes, how tall is a post that casts a shadow of 1.5 feet long? So here's a post, and it casts a shadow, and here's the sun. It's a happy sun, okay? And let's do all of the information set. So if the angle of elevation of the sun is 75 degrees 30 minutes, so with the horizontal, if it goes up this way, it's going to be angle of elevation. If it goes down, it's going to be called the angle of depression. And so that angle, not drawn to scale, is 75 degrees and 30 minutes, okay? Or 75.5 degrees. 30 minutes is going to be half a degree, right? And it casts a shadow of 1.5 feet. And what are you trying to find? How tall is the post? Let's call this x. Of course, we have the opposite and adjacent. So let's do a setup. Opposite adjacent, that's the tangent. So ka toa. Opposite over adjacent. So tangent of the angle is equal to the ratio of the opposite to the adjacent. Opposite to the adjacent. So tangent of 75.5 degrees is equal to x over 1.5. Cast to 1.5 feet. To solve for x, we're going to multiply by 1.5 to both sides. It's equal to 1.5 times the tangent of 75.5 degrees. I'm not going to do that on my calculator. You can just do that really quickly and get your answer. Okay. 34. Vector magnitude. Remember, the setup is half the problem. Solving it out is the second half of the problem. Vector magnitude, a vector v has a magnitude of 5. Vector v has a magnitude of 5. It makes an angle of 30 degrees with the positive x-axis. So here's the x-axis right there. It makes a positive 30 degrees. There it is right there, 30 degrees. And find the magnitude of the horizontal and vertical vectors. So find the vertical. Let's call this y. And let's call this x, question mark. Of course, x and y are always perpendicular to each other, and of course, the magnitude is 5. That means that distance is 5. So how do you find y? Y is, oh, look at that. It's a special triangle. It's 36 to 90. The short side is always half of the hypotenuse. It's going to be 5 halves, or it's equal to 2.5. I don't know if you can see that or not. Yeah, you can. And then, of course, on 36 to 90, this is x, this is 2x, this is x root 3, so it's going to be 2.5 radical 3. You can do it on the calculator if you want to try to figure out what that is, but I really don't care because I like to keep it in. exact form if possible, unless they want you to give it, unless the teacher wants the approximations. Did that make sense? Approximate approximations. Anyways, let's go on. 36. Velocity of a bullet. A bullet is fired into the air with an initial velocity of 800 feet per second. That's a pretty small, it's not 800 feet per second. It's probably going to be not a rifle. Rifle usually hits at about 1,000 plus feet per second. Most, like, I believe, smaller caliber firing arms. Got a phone call. I'm just gonna leave that alone for now. Anyways, smaller caliber guns, I believe, fire about maybe 400 to 500 feet per second, something like that. I haven't actually worked it out yet, but anyways, here we go. Angle of 60 degrees from the horizontal. So here it is. From the horizontal, it's going up 62 degrees. Oops, 62 degrees, and that's going to be 800. And what they want you to do on this one is from the horizontal, it goes up 62 degrees. Find the magnitude of the horizontal and vertical vectors. I'm going to mark it out with my little thing right over here. Somebody's trying to call me. It's okay. So I'm trying to find the horizontal vector right over here, something like this. And I'm also trying to find the vertical vector. Of course, here's your vertical vector right there. Okay? And let's call this a y. Why? Because it's on the y. That's why. Did you like that? Punny. Talking to myself too much. I think I'm going nuts too because I'm talking to myself so much. Anyways, so this is the x direction. It's the horizontal direction, and that's the y direction, of course. That's why it's called the y direction. So how do we do this? We could use opposite over adjacent. I'm just going to solve y, not x, and I want you to solve x on your own. So opposite over hypotenuse. Oh, look at that. Sine. There it is, sine. So sine of 62 degrees is equal to y over 800. And of course, solving for y right there, going to multiply by 800 to both sides. It's going to be 800 sine of 62 degrees. You can do this on my calculator. It's going to be 800 times the sine of 62. And it's going to be approximately 706. Approximately 706 feet per second. And I want you to figure out what the velocity in the x direction is. Of course, because this angle is bigger, about 60 degrees, the y component is going to be much bigger than the x component. Okay? And by the way, the x component should be approximately a little less than 400, because on a 3069, I know that the short leg is going to be half of 800, which is 400. Since the angle is just a little bit bigger than 60 degrees, it's going to be a little bit less than 400. Hopefully that's the case. I really don't care, because I'm not going to do the rest of the problem. Not my problem, your problem. Sorry about that. So let's do one last problem, true course and speed. This is one of the harder ones. I'm going to use the back here. Yeah, why not? Why haven't I started using the back? Save some money and save some paper too as well. Save a tree, right? I think I'll start using that to save a tree. Number 38. True course and speed. This is a rather difficult type of problem, but I know you've done some of these problems, so I want you to try to work this one out. A plane with an airspeed of 245 miles per hour, so it has 245 mph, miles per hour, and heading 128.5 degrees. The wind is blowing at a constant, so the wind right here, that's the plane. The wind is going at 45.5 miles per hour, and it's north 38.5 degrees east. Find the ground speed and a true course. And these are what we're looking for. Notice I always write down, not always, but try to write down what we're looking for in word problems. So a plane is going 245 miles per hour on a heading of 128.5 degrees with a wind speed of 45.5 degrees north 38 degrees, 38.5 degrees east. Okay, so it's going north and then in the east direction of 38.5 degrees. I want to try to draw this up and try to help you out. I'm not going to actually do this problem, but I'm going to help you out to set up this problem and then try to figure out the rest yourself, okay? Drawing is half the problem. That's north right there. And this is 0 degrees. Going this way is positive. Going that way is, of course, is negative. That's bearing. Don't forget, Santa Claus lives on the North Pole. It's always 0. Okay. So 128. So going from here, it's going to go 90 degrees in that direction. A little bit more. So it's going to go in that direction. In the fourth quadrant, 128.5 degrees. Let's draw it nice and big. 128.5 degrees. And I'm going to use a different pen here. And the wind speed, so we have to reset the north, south, east, west. So there's north again. Of course, it's parallel to this one. And it's going to be going, starting at north, it's going to go 38.5 degrees east. So it's going to go something like this. 45.5 miles per hour. Oh, I've got to put the information here. 245, that's 45.5. Okay, that's your velocity vector. These are your velocity vector. Remember, vectors have magnitude and direction. And so we look at this angle right over here. That's 90 minus that, which is going to be 38.5 degrees. We know that parallel line cut by transversal is going to be 38.5 degrees. We know that this is going to be 45.5 degrees. If you add that, 38.5 plus 45.5, 0, and then 8. What? No, 45. Sorry, 45, 128. Oh, 38. That doesn't make sense. Am I even doing the right problem here? It has to make 90 degrees. 128.5. Look at this on my calculator really quickly. 128.5 minus 90 is going to be 38.5 plus 45.5 is 84. That's interesting. Usually what they do is there's always going to be a right angle involved. North 38.5 degrees, 120 is heading 128. So it's starting at 0, 128.5 is going to be positive. So it's 90 plus 38.5. 90 plus 38.5 is going to be 128.5. Of course, that's going to be 128.5. Alternate interior angles. If I get a parallel line cut by transversal, here's the alternate interior angle. Oh, I'm sorry. That's 38.5. I got to find the complement of that. 90 minus 38.5, that's going to be 51.5. That's why. So that's for 51.5 degrees. If I add 45 degrees with that, I should get a 90-degree angle right there. Right now, you're really lucky because they will always give you a right angle. Okay? In about chapter 4, chapter 5, you're going to be dealing with non-90-degree triangle or right triangles. That's when you're going to have a lot of issues, like you have to use the law of sines or law of cosines and all of these other stuff. Okay, good stuff. Anyways, that's chapter 5 or beyond, so don't worry about it for now.